In last week's video, I spoke about creating modular tools in PCG. One of the things I was talking about was creating a system where you could just create a single spline and create this bridge, this wall, basically anything across a straight line, or you could just need to swap out meshes, but otherwise it is just repeating one or multiple objects along a spline with parameters. And today I want to show you guys exactly that. Here we have a simple bridge that I've just made with a few different assets. And this is just across one spline. So I can just go in, right, and change the length of this at any time, and it will propagate things accordingly. And it supports different things, such as the mirroring of meshes, accounting for the fact that these are facing a different way, as well as changing the spacing between the actual pieces or having them automatically be conjoined right next to each other, and the ability to have some of them just randomly appear or disappear. Basically, it's just a big data asset that you can just swap out, put in your meshes, specify if you want an extra spacing, a start offset, end offset, whether or not you want to scale or offset it, and mirror it to your heart's content. So that's what I want to show you guys. Create a simple modular setup where you can easily just swap it out and make presets for yourself for different configurations, whether it's bridges, walls, or anything that you're putting along a spline. Create one setup for it and reuse it in all your projects. Let me show you how to set it up. Here we are in a new project, and we're going to get started with setting up the data assets. So I'm just going to right click, go to blueprint, and grab ourselves a structure. This is going to hold all the variables that we want to be able to control. I'm just going to name it to be S_bridge tool. While this tool can be used for more than just bridges, it's just a name, so you can swap it out for anything you'd like. Let's go ahead and open it up immediately, and we're going to configure this with everything we need. Starting with the fact that we need a mesh of a type of static mesh object reference. Then I'm going to have an offset, which is going to be of a type transform. So this is to offset the location of any of the meshes. The next one here is spacing offset of a type float. So this way, instead of having objects right next to each other, you could say, give them an extra 100 space, 200 space, 300 space between each one. So in the situation where you have pillars or something else that you don't want them right next to each other, you'll be able to control that. Next one down is mirror of a type Boolean. Pretty self-explanatory, right? If you want to mirror it to the other side, then we have a mirror as just a checkbox. Then we have a start offset of a type float and an end offset of a type float. So start and end offset is basically start and end of a spline. So basically, if you wanted to not do something at the end specifically, you could use the start and end offsets to kind of shrink it in a little bit. Depending on your setup, if your pivots, let's say, are always in the middle, your first point might end up being before the start of the actual spline, effectively. So maybe you just offset that piece by half of its length, and then it will start where your actual spline starts, effectively. Same thing with the end. And the last one I have here is random prune. Basically, we're just going to filter out points if we want to actually remove a few randomly. And I'm doing a random prune. So basically 0 means you're keeping everything, and 1.0 is you're removing everything. In PCG, we have the ratio. So 1.0, you keep everything. 0 is you remove everything. Doesn't really matter which one you do. The only difference really is a 1- node, whether or not you add it or not. And I feel like that is very much a kind of a user preference thing. Some people like to specify how much they're removing. Some people like to change it to how much they're keeping. But that's all the variables we need. That is all of the controls we're adding. And you, of course, can add a bunch more here. These are just the ones I'll be showing in this tutorial. I would recommend building upon this and expanding it to fit your needs. So awesome. We have the struct. So now we can close this and create ourselves the data asset that's going to house all this information. So I'm going to right click, go to blueprint class. I'm going to open up all classes, and we're going to search for primary data because we need the primary data asset. Go ahead and select it, and I'll go ahead and just name it to PDA_bridge tool. And then I'll go ahead and open it up. By default, this doesn't really have anything here, but all we need to do here is just add our variable that we just created, the struct. I'll just call it bridge vars or bridge variables, and the type here will be S_bridge tool. So we'll go ahead and select it, and I'll just right click on it to create an array out of it. So we have an array of the struct. I made a struct and I put it in here. You don't need to make a struct. You could just populate all of these variables right directly in here without a single struct. Personally, I find it a little bit easier this way, because that way, once we get into the data asset, it will all be kind of grouped together. And I'll show you why in just a second, because we're done in here. Now we need to create the data asset itself. So we'll just right click, go to data, and right here, is data asset. You want to grab this, and it's going to ask you for the class. And the class is this one, right? That's the PDA that we just created. So we just do PDA underscore bridge tool. Go ahead and select it. And I'll just call it something like DA for data asset underscore bridge underscore A, because this is the modular piece. So if I open this, this is the bridge variables you see here. And you can hit plus, and you can see all of them come together. And if I hit plus a few more times, right, this is why we put it into a structure. It makes it nice and simple and organized this way. So now we have an array of 3 things, and this is all of the configurations for it. So now what I can go in as just populate this, let's say with a structure wall. And so this will be the first piece. Now I'll go through and fill this in. So here we go. I've populated everything with the configuration that I want. So we have the actual, it's called structure wall, but we're using it for the ground, fences, columns, overhangs, and some barrels. And we'll go ahead and make use of this. And as I add functionality to each one, we'll of course go into it. So cool, we now have this. So this is kind of the setup for the actual assets and basically the modular part of the configuration. So we can make a bridge B, bridge C, bridge D off of this guy, or rather off of the PDA. We just duplicate the bridge A, right? If we want a bridge B, we can configure bridge B to be something different. But now let's go ahead and get started with the actual PCG graph. For that, we're going to need a couple of things. The first one is the blueprint class. So we're going to need a type actor here. I'm just calling it BP underscore bridge tool. And the second one is going to be a PCG graph. We're going to need one main graph. So we'll create an empty graph here. I'll call it PCG underscore bridge tool. And we'll need one other one. So I'll just duplicate it and rename the second one to PCG loop underscore bridge tool. All of the logic really is going to be in this loop, actually. Because what we're going to do is take every single unique asset or every single unique input, basically, that we have in the data asset and spawn something along the spline with our configuration. So we're going to be looping on each one. And with the way it's being configured, you can take this loop pretty much anywhere you want. And that's why we're having it as a separate thing instead of having it be built in, because that is now a feature in 5.8. So that way you can just take it anywhere you want. You just need to plug in the data asset into it, and then everything will work. Okay, so we have this. Let's go ahead and configure the blueprint. So with it opened up, we'll add just a couple of things. The first one is just a spline, just a regular spline. And personally, I like to extend it a little bit, just so it's a little bit longer. And then I'll go ahead and add a PCG component. And here you want to plug in the regular bridge tool, not to the loop. You want the main graph in here. We just compile it, and then we just go ahead and grab it and just drag it out into the world. At this point, we just select it and just drag it out to be whatever length we want. Nice and simple. So let's get started with the main PCG graph here. Let's go ahead and open it up. And right away, actually, I'm just going to take the bridge tool, the loop one, drag it in, and select a loop node on the bottom. So that way we have it here when we're ready. But here it's very simple, actually. We just need to go in the bottom left into graph parameters, hit the plus button here so we can add a new one, and then hit the green capsule here, and then we can change the type. And we want to change the type here to the PDA underscore bridge tool, not the data asset. We want the primary data asset of the bridge tool. Go ahead and select it as an object reference. And from here, you'll see the drop down will show you just the one data asset you made, or as many as you have made so far. I'll go ahead and select one of them by default, so that way we always have it populated. And I'll just click on the new property and press F2 to rename it. I'll just go ahead and call it data asset. So very nice. So now we have it. We can now drag it into the world. There's our data asset. If I pressed A here on it, you can see we have the actual data asset, but we need to actually get the information inside of it. To do that, all we do is drag out and search for get property from object path. Once you select it, it will error out. That's fine. We just need to configure the settings. And the main here is the property name. This is the name that we specified right here in the PDA file. So I'll just go ahead and grab it. I'll just copy it over, come back here, and I'll paste it into this property name. When I press enter, you'll see that the error has gone away. And now if I pressed A on this guy, you will see, hey, there's the mesh, there's the offsets, X, Y, Z, the rotations, the scales, right? All of our variables are now in here and populated. So awesome. We have that. So now we can just go ahead and partition them. So if I search for attribute partition, and with the thing we need to partition it on is index. So open up the partition attribute selectors, press plus, and select index. So now if I go and select and press A, you'll see just one entry here, but in this drop down, you will see all of them have been put in here. So we have 5 entries, and each one is going to be split up by its entry. So each one has its own mesh column. And the reason we do it by entry here, you might want to have the same mesh in multiple places. So maybe you want it to be like on the sides and on the top. And this way it doesn't get confused. It makes sure to do everything it needs to for every entry as a unique thing, using whatever configuration you've set up. That's all we need here. And honestly, at this point, we basically just need the loop. This is really it that we need here. Like I said, majority of it is going into this loop. So let's go ahead and start configuring it. I'll open it up by double clicking it. And this is going to be a very simple setup. We'll just open up the pins here. We just need to change the usage here to be a loop. The allowed types is actually an attribute set because we're setting in the data asset. So it's going to be an attribute set. And pin status, instead of advanced, we'll say required. And honestly, that's it. We don't even need the output. You can output some stuff if you wish, but it's not required. We just need the data asset looping through it. And now in the main graph here, we just need to plug this all the way through. And now whenever we actually make adjustments to the loop, we'll actually see all of the things happening. So let's take a look. Back inside the loop, we can start configuring this. If I just select it and press A here, you will see there's all our attributes. So awesome. So it's all coming in. We're getting everything. And you can see here, we only have the one because it's a loop, but we can select a different actual array index here. And we can see the information for all the different ones. We're going to need access to this information down the line. So I'm just going to use a named reroute node by searching for named, and we'll add a named reroute declaration node. This will just make it easier for us a little bit further down, so we don't have to drag all the way from the input. Let's press F2 to rename it, and let's call it data asset. So cool. We have this. Now we know we're working with a spline, so we can just right click and do a get spline data. So once we have the spline data, we'll of course need to sample it. So we'll do a spline sampler afterwards, right? So we're sampling it, but this is where we already need the information that we were putting into the data asset, right? Into here, I want to specify, for example, the distance increment, right? I want to specify how far do I need to space things out. And unfortunately, you cannot add all of these attributes just to this spline. We need to add it to a point first. So let's do that. We'll add the information to a point and we'll use that to do any calculations we need. For a point, well, that's easy. We just can grab a create point node and it's just going to be default to one single point. And that's really all we need. We just need something to house the information and to assign all of this information onto it. We just need to use a match and set attributes node. So what this is going to do is take all of the data asset information and assign it to this point. So if I pressed A on this one, we can see that there's the point information at origin. And if we scroll to the right, there's our mesh, there's the offset, right? All of those attributes have been added to this one point. So fantastic. Now, why are we adding it to this point? Well, as I mentioned here, I want to know the distance increment. The reason I want to know it is because I want to know how big is the object and automatically place the next one that far apart. So that way, by default, they're always going to be perfectly touching each other. When making things like walls, bridges, or kind of any kind of road system, right? You're going to want them perfectly to be right up to next to each other. And this way you don't have to do any calculations. That is the default state. And then from there, you can offset more or less. To find out how big the actual mesh is that we put into the data asset, we can use a bounce from mesh node. And of course, it's going to need an attribute. So in the detail panel, the attribute is going to be mesh. Because if you recall, and if I press A here, right here, mesh is what we called the variable that houses our mesh information. Basically, it's going to take the mesh and apply it to the bounds, so it knows what size it is. But the bounds are a little bit interesting in how they're stored. They have a minimum bounds and a maximum bounds. Now, we want basically the full length. So the bounds don't really help us. But if you have the bounds set, you also know the extents. And the extents is basically the radius in a certain axis. So along X, the extents is from the center to whatever is going to be the furthest point, and it's going to be the same in both directions. So you can take the extents and double it to effectively get the length of an axis. The first thing I'm going to do is copy that information somewhere else into my own attribute. So I'll do a copy attributes node, and it's going to go from and to the same thing, right? It's going to go from and to itself. And here under input source, I'm going to hit the plus. I'm going to go to point extents. But I want to do extents dot x because x is the forward axis, and that's what we're using. So I want to do extents.x and copy it somewhere else, and I'll call it length. Copy the extents.x to length. So if I come here and pressed A on this node, we can scroll all the way to the right, and you'll see there's length of 50. So that is the half length, right? We need the full length, so we need to double it. Now I could double it now, but I actually want to first convert this whole thing into an attribute only, because we don't need this point information, right? We only need the attribute information. So from here, I'm just going to do a point to attribute set, and this is going to call all of these $ ones. So this density, steepness, seed, all of this is going to go away. If I now sample this, we're just left with the attributes. And that is why we went ahead and copied the actual extents of the point before doing this. So now we have the length of 50, and now we can go ahead and multiply it. And we'll multiply it by 2. If I press A here, you'll see length of 100. Now I didn't specify what I'm actually multiplying, but by default it is at last, and the last modified thing that we did was length. If I want to be specific, I can specify length. That way, if I do it anywhere else, like if I did any other modifications first, it will still only modify the length by 2. So now we know that the actual length of this piece is 100. But at this point, we still have all the other information, and we don't want it. We just want the length. So to filter out just the length, there's a few ways of doing it. One of them is using a delete attributes node, because in here, we can say, instead of delete selected attributes, we can keep only the selected attributes. And I want to keep only length. And if I take a look at it now, and I pressed A, there's the length only of 100. That is the only thing we have. So okay, so that is the spacing that we need for this spline sampler. But here's the thing. If we did this and plug this into our distance increment here, right, let's put it in right here. This won't get us all the control we want, and I'll show you why in a second. First, let's go to the spline sampler and change the mode here from subdivision to distance, which opens a bit more controls here if we wanted to. And we'll go ahead and have it spawn the meshes right away so we can start previewing all the stuff we're doing. Now, unfortunately, we don't have access to the mesh here, right? We did the actual mesh stuff here. We added the information here. And really, I only did match and set attributes just to show you that you can copy all the information that you need. We only needed the mesh here. We didn't need everything, but we also need it here. So I'm just going to right click and type in data asset so we can grab the data asset reroute that we created just over here. And then using a delete attributes node, we can go ahead and just remove everything except the mesh. So if you want to add just the mesh, we can, or we can do the same thing and use a match and set attributes, and it will go ahead and just assign everything here to these points. So if I pressed A here now, there's all the points, and there's the mesh, offsets, and everything else, right? You can add just one, or you can add them all using a match and set attributes. So cool, we have this. So now if we just used a static mesh spawner, we can specify to use the mesh attribute. So on the static mesh spawner, we'll just change the mesh selector type to by attribute here, the first one, and the attribute name is mesh. And already we can take a look and, oh, there we go. It is spawning right up against each other for all of the meshes. And that's the thing. It is right up against each other, but we don't want them right up against each other, especially these columns, right? They're a bit off. We want them spaced. So here, where we're doing the distance increment, we actually want to go ahead and offset this distance. And we'll offset it by a variable we set up. So I can go ahead and grab this data asset here, copy it here, and then we'll use a delete attributes on it. And I'm going to keep, instead of length, spacing offset. So how much extra spacing do we want? And it's now as simple as just adding both of these attributes together and plugging them into distance increment. So we've calculated the distance of the mesh, and then we're offsetting it by our value. And now, would you look at that? We now have them spaced out pretty well. So awesome, we have the distance increment working. Let's add the offset next. So right before the static mesh spawner, we'll do the transform points. So we'll drag out, use a transform points node so we can go ahead and offset things. And before I forget, because it's very easy to, on this transform points node, make sure you turn off uniform scale. Otherwise, you wouldn't be able to scale those non-uniformly. And just like we did here, we'll grab the data asset and the delete attributes. We'll copy it over here. But in this one, I'm just going to grab the offset, which is a transform. Right? If I pressed A here, you will see there's our position, rotation, and scale transforms. So we have a transform, but we need it broken up for the inputs. So all we do is just drag out and do a break transform attribute. And now we have each one split up. And now it's as easy as plugging in translation into offset min and max, rotation into rotation min and max, and scale into scale min and max. Just like so. We close this up and clean this up a little bit. And now, just with this, okay, the pieces are now adjusted. This column is now bigger. These have been risen up and offset, but they're not on both sides, right? We need them off of here onto the other side as well when we turn on mirror. Because maybe you want some of them to be on one side, some of them not, and this will allow us to control that. To achieve that, before this transform points, I'll just go ahead and scoosh this to the side a little bit. I want to use a branch. Basically, we need to give it a condition, and when the condition is met, it will be output B, but when it's not met, it will output A. So when it's not met, it'll just output A as it did before. But if it does meet the condition, we still want to do output A, but we also want to do a second thing, right? Because we want to do the first side and the second side. The second side will be the same pretty much. So we'll just duplicate this and kind of plug all these through. We'll just need to make a little bit of a modification to this. But first, let's go ahead and plug in the output to be here. Just like the other ones, we'll just go ahead and copy the data asset and delete attributes. And this one will be the mirror attribute. And that is going to be our output to be here. So we'll just plug that through. And when this is true, that means we're mirroring. So we're going to do still the one side. And for the other side, we want to mirror to the other direction. So I want to flip the y-axis on the location. So off of the translation here, we can just do a multiply. And this will multiply the entire thing. We don't want to do that. I want to multiply specifically offset.y. Because if you recall, our forward axis is x, perpendicular is y, and up is z. So if we offset y into the other direction, we'll be mirroring it over. So we'll do a -1 of offset y, and that becomes the actual offset here. Now, if we just did this and then took output to be and plugged this in here, and then had the output of this go into the static mesh spawner, it will mirror it, as you can see here. But it will not mirror this, which is a rotation thing, right? It is now facing the same way on the other side, and we need it to be, well, flipped, right? It needs to flip the entire thing. To do that is very simple. We also need to actually flip the scale. So we'll just duplicate this multiply and take the scale, plug it into in A, and then we'll take this and plug that into here. So now it is also scaling it -1 in Y. And if we take a look now, hey, look at that. That is now fitting really well. So okay, so that's much better. We're not quite there yet. These pillars are actually right in the middle of this. I actually want to offset them. The reason they're there is, as I mentioned earlier, they're being placed relative to the start of this. I could move this entire thing over, but in my case, I just want to move the pillars over, which is why we added the start offset and end offsets. So to use them, we just need to modify the spline sampler here and plug in our start offset and end offset. If you go ahead and select it, you'll see those are two sections you have when you're working with distance. So we can just take this, delete attributes, duplicate it a few more times, plug the data asset into those. And then on the first one, instead of spacing offset, it is start offset. And on the second one, it is going to be end offset. Pretty much I just copy the names that you see right here. Now start offset goes into start offset and end offset goes into end offset. And we can close this up, move things around to make it a little bit cleaner here. But now if we take a look, now our column here is now actually placed where we want. It is now in between these, which is significantly better. The last one that we kind of have set up and we want to do is remove some of these barrels randomly. We don't want them at every single one perfectly. So we will adjust a pruning, but we'll do that after the mirror. Because if you did it before the mirror, then we'll mirror perfectly. And I want to make sure that the mirror is not perfectly actually split up. So from here, we just need to use a simple select points node and make sure both of these are still going into select points. But this gives us access to ratio. So let's plug this all the way through. And this is where I was saying that it really depends on how you like to work. But in our case, I'll just grab our data asset and delete attributes and then specify the attribute that we want to use as our random prune. Now, because random prune is 0, because we want to keep everything, so we're not pruning anything that's 0, and this 0 would be we've lost everything, we just need to use a 1 minus node, because right, 1 minus 0 is 1, so it basically flips it, and that is our new ratio. If we take a look now, it has gone ahead and removed some, but one thing you will notice is it has removed them exactly the same on either side. Whenever there's one on one side, there's exactly one on the other side. The reason for this is because when we go ahead and do the mirroring, the seeds of each of these points is exactly the same. And that's what it uses to actually decide whether or not it wants to keep them. Thankfully, that is a very simple fix. From this mirrored version, all we need to do is do a mutate seed, which will basically randomize the seed again for all of these points, but since we're only doing it on the bottom one, the top ones will be different. So we can just go ahead and detach this one and plug this one all the way through. And now if we take a look, hey, they're no longer on the other side, and some of them, right, are going to be very different, and we'll occasionally get the same one on both sides, of course, but this is now just randomness. This isn't like a set thing, as you could tell. But honestly, that's it, right? That is all of the controls. So now if we wanted to, we can go in here, duplicate this DA bridge A, and we'll call it B, and then select our actual graph, go down to the PCG component, open up the parameter overrides, and we can override this data asset and plug in B. Now, nothing has changed because we haven't configured B, but if I come here and start configuring B, let's say I want the columns to be bigger, so we'll just scale them up just a tad, and maybe I want the overhangs to be a bit lower, let's say 20 instead of 70, and we'll probably need to offset the barrels also by the same amount, so they'll be also 50 lower, and I'll actually want to keep more of them this time, so I'll only prune like 20%. And now, there we go. We now have a separate setup where we have these bigger columns and the barrels now are on lower shelving here. Now, it doesn't really make sense here how they attach, but don't worry about that, right? The point is we can now go in and just swap out this from just the drop down into the different configurations if we so wish. So you can just make a few preset configurations and then just have someone go in and just say, okay, we're doing this kind of bridge here, or this kind of bridge, or this kind of wall, or anything of that sort. And bam, it is now set up for everyone to use with ease. They just drag out the blueprint and choose the data asset they want to use. Simple as that. And because of how it's set up, there's nothing specific for this project here. The only thing specific is you need to have the data asset set up. But even that is technically not required in the sense that it just needs those attribute names to be the same. If you need like a one-off somewhere else, you might just want to expose all those parameters yourself inside of a PCG graph and then just combine them all together and pipe them through as I did basically here. Or create a different data asset, but as long as the names of those variables was the same, it would still work. So it doesn't need to be this specific data asset. It just needs to be any data asset that has those same variable names right in the same relative location. And then everything will work very well. So now you can go out there and use this tool in pretty much all of your projects and simplify your workflow quite a bit. And if you're wondering, I've been using Kenny's assets here as always. And if you'd like, the project file will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the link to the Discord and everything else will be in the description below as always. And if you haven't seen the video I was referring to talking about how I use PCG, I really recommend you checking it out to understand how I look at and tackle PCG. I know you're gonna like it.